Hi, welcome to another installment of Old Farts Talkin' Tech. So this week I'm going to start a new project, and it's going to be using one of my new favorite platforms, an Arduino. These little suckers can do an awful lot with not very much, and they're cheap. So I'm going to be using the Arduino to create a water sprinkler controller for my house. Now, you might ask, why do this? These have been around forever. As a matter of fact, my good friend and another old fart who loves to talk tech, Ken Cadlick, texted me when I proposed this. And he came back and he said, this is Ken's law. If something exists and it does exactly what you want, don't waste your time reinventing it unless you have absolutely nothing better to do. And I kind of agree with that. On the other hand, I'd like to add one little corollary to that. If you learn something by doing it that you can apply to other things, it's still worth doing. So yeah, I agree that water sprinklers have been around for a long time. They have a lot of nice features. But I think using this Arduino and a few other little tricks to get this going is going to be interesting. I'm going to learn a lot from it. And it may give me some capabilities that I didn't have before. So let's get started. And yeah, we might even learn a little bit about other things like soldering and, how to make LEDs work, stuff like that. So here we go. The sprinkler controller that's in use now is the HR6100 unit from Irritrol. Judging from the controls, I'm guessing that it's about 30 plus years old. The user interface consists of electromechanical rotary and slide switches to set watering times and run times. It can only control up to 6 sprinkler valves and has a repeat cycle of a week. It uses a 9-volt battery for backup, and it has a 4-digit NIXI-type display to indicate time of day and sprinkler runtime. The unit is still somewhat functional, although after decades of use, the contacts on the rotary and slide switches have become worn to the point that they're no longer reliable. I'll be replacing this unit with a version of the Arduino base system shown here. This is an original design created by Bulldog Lowell that has a detailed step-by-step instructional video created by Pete Will. More info on this can be found on the website listed in the photo. As you can see, this design incorporates several features that increase its versatility. The user interface is now a smartphone app that connects to a wireless transceiver module connected to the Arduino. There's an alphanumeric LED display that indicates system status and operational mode. Up to 8 sprinkler valves can be connected to the Arduino-controlled relay module. As I start into this project, there's a couple of interesting design challenges that I see. First, I notice that the power supply for the Irritrol controller is a wall brick that converts the 120-volt AC house supply to 24 volts AC output. The reason for this is that the solenoid switches on the individual sprinkler valves operate off, you guessed it, 24 volts AC. Here's a picture of the wiring system from the Irritrol controller to each sprinkler valve. The 2 far right screw terminals with the black wires are for the 24 volt AC input to the Irritrol controller. The white wires next to them carry 1/2 of the 24 volt AC output from the controller to the individual sprinkler valves. This output from the controller is common, meaning it's connected to all the sprinkler valves in the system. The set of colored wires to the left are the switched 24 volt AC outputs to each of the sprinkler valves. So the way the controller works is to control the switched AC outputs to each sprinkler valve at a time that is set up by the dial switches on the front panel. When the switch is activated for a particular valve, the sprinkler turns on. When the switch is deactivated, the sprinkler turns off. So the core of this project is to replace the ancient dial-based controller with an Arduino-based microcontroller that can be accessed from a smartphone. One of my first tasks is to make sure that I can generate both the 24-volt AC output for the sprinkler valves, as well as the necessary DC voltage to power the Arduino and peripheral circuits. Here's a block diagram of my sprinkler control system. There are some parts of this design that are different from the original Bulldog Lowell design, so let's step through it. As I mentioned, it's necessary to supply a 24-volt AC signal to the sprinkler valves to turn them on. And the Arduino module I'm using, as well as a couple other components, need a 5-volt DC supply. Rather than having to plug in two different wall warts for these voltages, I found an AC to DC converter module that accepts a 24-volt AC input and outputs 5 volts DC. So this means I can run the whole system off a single 24-volt AC supply. By the way, I'll be publishing a component list for this project in a separate document. So I connect the 24-volt AC input to a screw terminal block that has half the AC voltage on one side and the other half on another. One half of the AC input is connected to a common wire that is routed to all the sprinkler valves. The other half of the AC input is connected to a relay module block. Each of up to 8 relays on this module are controlled by a signal from the Arduino controller. So when a signal is output from the Arduino to an individual relay, that relay connects the 24-volt AC signal to a specific sprinkler valve, and that valve opens to water that section of the yard. The Arduino controls when and for how long each sprinkler valve is open by getting day of the week and time of day information from the DS3231 real-time clock module. This handy little module has its own battery, so if the system loses power, the real-time clock module will still know what time it is. Because the Arduino module has a limited number of I/O ports, it's always a good idea to keep the actual number of ports used to a minimum. For this reason, I used a 3 to 8 line decoder chip as the interface to the 8-channel relay module and saved 5 I/O ports in the process. Here's a video clip of the assembly and wiring process for the Arduino to the various module connections. Since this is a prototype, I chose to use a printed circuit breadboard and wire wrapping for maximum ease and flexibility. For those not familiar with the ancient art of wire wrapping, this clip shows how it's done. You start with 30 gauge wire wrap wire and the magical wire wrap tool shown here. This tool incorporates a wire stripper and the wrapping device all in one. Once you've stripped about an inch of wire, you thread the stripped wire into the long end of the tool so that it sits in the tool's wire channel. Then select the first connection pin and insert the tool over the pin to be connected. Twist the wire wrap tool until the stripped wire is completely wrapped around the pin. Next, locate the endpoint connection pin, strip the jacket from the other end of the wire, insert that end into the tool, and twist it onto the pin. Now you have a secure connection on both ends that can easily be disassembled if you make a mistake or your connection changes. Here's a picture of the fully assembled controller with the Arduino programmed to run 4 sprinkler valves in succession on Sunday, Tuesday, Thursday, and Saturday. I've also set up the Arduino to print out to a serial port the start times of each valve. So far, I'm happy with the way this project is coming together, and the ease of programming the Arduino. There's a lot more I'm planning to do with this system. You ain't seen nothing yet. Thanks for watching, and if you enjoyed this, make sure to like and subscribe.